Good evening, everyone. This is Luther P40. I was just going to go over quickly, or hopefully quickly. Well, you know me, I can't do anything quickly. I'm trying to go over explaining how to calibrate your YAHHO HHO flow meter. And basically, what I've come to discover is that each one of these measuring devices have their own opinion as to what 100 milliliters is, which means you gotta have something you can trust to know what your measurements are. Which means basically these are good enough for cooking, but they're not good enough for measuring hydrogen gas. Yeah, that was my mistake. I learned that the hard way. But as it turns out, I had one that I was able to actually calculate to verify that it was measuring correctly, because it's a perfect cylinder. Well, as perfect as man can make one, but it's a perfect cylinder, and it has the increments going all the way up from 0 all the way up to 440 milliliters at the top end. And I can use this one to actually use math to calculate if this scale is correct. And I come to conclude from measuring the volume, measuring the diameter of the opening, and then calculating what the volume needed to be between 2 points on the scale. I come to believe that this is probably the most accurate of the most accurate of the measuring cups that I've got available to me. So as it turns out, I'm not actually using this one to calculate or to set the marks on my scale. I use the same formula. Of calculating the volume of a cylinder to decide where my marks go. And then what I ended up doing is I compared my marks against this measuring cup right here. So I'm pretty comfortable that it's pretty daggum accurate. I mean, I believe I could use this one to tell you that one of these cups are wrong. But basically, what I did, the inside diameter of the tube is 1 inch and 21/32. It's calculated out to be 1.65625 inches. Converts to millimeters is 42.4 diameter. Radius is 21.2. Area of the plane in the tube is, unless I've gotten my decimal points in the wrong place, is 1,411.957,402 square millimeters. And then I just use that as my that value right there as my constant to calculate how much the distance needed to be for each one of these. So there's a 100 millimeter mark, 200, 300, 400, 500, 600, so on, all the way straight down. My column for millimeters, column for inches, and this is a fractional inches. All these dimensions, this dimension right here, or either one of these two dimensions right here, is all measured from zero, from your 0 point, and 0 is calculated when this is all the way down and you make a mark at the top of your outside exterior tube, and that's going to be 0. And everything measures off it yet. So what I would suggest you do is, I mean, if your tube is different diameter than this, you can't use the data that I collected here. You'll have to do your own math to figure it out. But everything measures off of here and is cross-checked with the distance shown for the inches. So this 2 inches and 25/32 right here, this dimension right here, that was after I did the dimensions from 0 to 100, 0 to 200, 0 to 300, 0 to 400, 0 to 500, 0 to 600, 0 to 700, and so on. Then I came back and double checked to make sure that I had 2 and 25/32, between from here to here, 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 and so on. And it's basically confirming that I did my math correct, because these marks are all going to be the same thing. I mean, you could just as easily have taken this mark right here and started at 0 and just gone up 2 and 25, 30 seconds all the way up. But once you're happy with your marks, in other words, when you put you have your 0, you make a small little mark where you intend the measurement to be. And when you're happy that you've got those small marks where you want them, then what you would do is the way I did it, I don't know if I can do this while I'm handed. Okay. The way I did it is I would bring that mark that I liked to the top of the cell right here, or top of the outside 2, and I would take my magic marker and marked it all the way around to continue the mark all the way around the circumference of the tube. And I did that for each one of those marks. And after I had that mark in, when I had those lines in place, that's when I went ahead and added the measurements, like 0, 100, 200, 300, and so on. Now you could go and add more marks in between, but this was yeah, I've been messing with this. I've been messing with this thing for about an hour and a half, 2 hours, trying to get it just where I was happy with it. So, I mean, part of it was I had to figure out how I needed to measure it, and it all came back to that you can't trust these measuring cups, which meant I had to come up with another way to figure out how to mark my tube. I mean, you can't trust them. They're not. I mean, I could take 800 milliliters out of this and pour it in this one over here, and it would read different. So it's like I couldn't trust any of them. And like I said, this one right here I could trust. And the only reason why I trusted it is because I calculated it out. I measured it out. I said, well, show me where the mark's supposed to be for 400 milliliters. Using math, and it came up on the mark where it said 400 milliliters. So I said, well, I'm thinking that's pretty daggum accurate. Well, more so than anything else I got in here. So, alright, I'm just I don't know if there's a couple of little modifications. I had to add some silicone to the top of this. This cap wasn't really intended to hold back gas. And the other thing I did here is I replaced that tape that you saw in the other videos. Now I've got one that's perfectly flat. But what I have here is I have a smaller piece on the inside. I can't pull it out, but I have one on the inside that seals up the inside of the opening, and then another one on the outside, and the two pieces of tape are stuck to each other to help hold them in place so that moisture won't get underneath it and have the tape release. But I believe I'm calibrated now, finally. It's one of these things, and I thought this was going to be the easiest part of the whole thing. It turned out to be the most difficult part because I want it to be accurate. So, I hope they find this information useful. And if I missed something, or if I misled you in some way, just give me a shout, and I'll see if I can correct the information and make it right. Anyways, this is Luther P40 signing off. Thank you very much for taking the time to watch my videos. Take care.